Over here, wherever the camera is. Hi there.
Can we go to the podium?
Oh, you can do it from here.
Okay.
Can everybody see these guys? So welcome to our final TWed of the spring 2025 semester. We're really excited. We've got Devin and Nipan who have been made amazing progress this term on advancing ChatBS to what we call ChatBS-NexGen. Just a couple of logistics. We are recording this for eternity on the interweb. I think that they're welcome to ask questions to you guys. Is that right?
Yeah.
Right. And they've got some overview slides, but also they're excited to get on to the demo. So without further ado, take it away. Thank you, guys.
Okay. Thank you. So I'm John. This is my colleague Devin. So we are going to present today about our work that we have been doing for the past semester. So it's ChatBS-NexGen, basically a platform for automated knowledge graph-based LLM fact checking. So when we start to talk about the origin story of this application, like usually when we look for LLM, there are multiple ways to evaluate it, from the aspect of clarity, from the aspect of relevancy, as well as out of all, it should be factually accurate. So currently, there are multiple benchmarks available to do factual accuracy, such as like TWed, truthful QA, as well as multiple scores called like rogue score or blue score. But when it comes to domain-specific pre-trained LLM, such a standardized mechanisms won't work, simply because those datasets or the scoring mechanisms are specialized for general scenarios. So the main point here is we need to fact check the LLM or the RAG system we have at our hand on the given set of scenarios under the given set of cases. So currently, most of this kind of validation would be happen on manual hard labor. It's going to be a pretty time consuming as well as rhetorical, since the validation process would be ideally kind of repetitive. So since we try to formalize this validation process, and based on that formalism, we try to make it automated. Finally, after all like conceptualization, we came up with three main features. First one, formalization of the validation as a pipeline. So as you would imagine, to validate, first we need to generate answers out of the LLM. Second, we need to get out the entities or the information that we need to validate. And third, we need to have the ground truth information to validate against. Finally, we need to do side-by-side checking or any kind of validation against the generated information and the ground truth information. So as I explained, there are 4 steps in the formalized validation pipeline. So since we've been formalizing this validation process, we had the capability to customize. So you will see in the ChatBS-NextGen application, we make it very usable to customize that pipeline process for any kind of scenarios you got. And finally, final feature is use of knowledge graphs as the ground truth knowledge. So one reason to go for the knowledge graph is we are being semantic web people, and more technically, the reason is going for unstructured data would create more hassle, because first thing, we can't extract out semantic information out of unstructured data without going for non-rhetorical work. And knowledge graphs are itself created from entity relationship mappings. So that's the reason to go for the knowledge graphs as the ground truth knowledge. That being said, now we need to discuss what is ChatBS and how it works. So ultimately, there are 2 parts: pipeline generation that makes the formalized validation process. And the second part is the experiment run. So that ultimately give us the results for given scenario on the given LLM. So first, let's go into the pipeline generation. As I explained, there are 4 steps. First, we need to define the scenario. So in the LLM setting, we are generally set up this kind of scenario by using the system prompt. As it seems, so user should set the system prompt instruction to generate the system prompt template. One reason to go into the template information is, as I explained, not only the scenario we need, but also the user cases. So to set the user cases, we need to pump up the user case definition information into the scenario text. So that's why we are building a prompt template where has a couple of placeholders to put the case specific information into it. So the second part, the extraction instruction, that semanticize from what information we need to extract out of the generated answer. So for that, we have a entity extraction function, and user need to give the query template. Specifically here, the query template should be in Sparkle template to show the system this is the information you should validate against. And finally, we need to have a post-processing step to get all the information into a single understandable format. So, as you would see, when user given all those 4 instructions to the system, it will go into the LLM-based function generator. That means the sum of functions are aid LLM's capabilities to generate functions. For example, when we given the prompt instructions, but there is like missing part to intelligently design that placeholders, such as well as in the extraction instruction phase, user could only give this thing is what we need. But to create a function, we are using LLMs in that scenario as well as in the post-processing. So when we got those 4 functions, pipeline composer would create a portable pipeline that is not only the machine readable as well, but also it is human readable. Then, as a final result, we will get a portable pipeline configuration in this scenario step, and then we can go into the interesting part, basically the experiment run. So we'll feed back the return from the pipeline generation into the system to build back the pipeline and make it executable. With this, we can set up any kind of data set to set the user cases for the experiment and the LLMs. So here, one thing to mention is we kind of make the experiment process and the generative process decoupled. That means in the pipeline generation process, you don't need to mention the mechanism how the answers are generated. So that can be defined in the experiment process itself. That's what we are doing by mentioning what are the LLMs or the generation process you should use in the experiment process. So when all being given to the system, it will spin up the experiment runner and give us the answers in real time. So that's the brief overview to the system. Without further ado, let's go into the demo. Okay, give me a second. I need to get out of. And back to the bed.
For those online, we're waiting for them to bring up the demo right now.
Yeah.
But in the meantime, we were waving at you.
Yeah,
Yeah. We're enjoying our pizza and salad.
so far Brazil is the farthest away.
Yes, thanks, Vladia.
Yeah.
Hello, thank you. How are you? I miss you, everyone.
We miss you too.
Hello. Okay. All right. So I'll take you through the demo. So like I'd like more there. Okay.
Yeah.
All right. Okay. So again, uh, uh, a little bit of refresh. We have two steps. One we like we said earlier, we're gonna decouple the fact that we can create the pipeline to a specific scenario. So for example, we have some patient data and we want to create, okay, what are the best recipes for those patients? So a scenario like that, we want to decouple the fact that we can create a set of functions to evaluate this and the data set that pipeline is run on. So now initially I'm going to show you how you set up that pipeline, which is basically how you generate that functions for those use cases. So in our application, we have like several pages. One is experimental run, which is where we kind of do where we run the experimentation. And then on the next side, we have setup pipeline. Here so the idea is, okay, like Nipun earlier showed, how do we get like natural language instructions to create a specific pipeline or specific functions to do what we want to evaluate that specific scenario. So let's say, so if I explain again what the functions are, the first generation part of the system, the idea is to, okay, we have a set of patient data. How are we going to okay, I have a set of patient data and I want to create energy boosting recipes or gym work food for that specific thing. So okay, now we have specific user case of a single patient saying, okay, he has diabetes, he has he specifically is vegetarian. So that specific information that the underlying user prompt or build me a recipe should have is injected to the LLM using the system prompt. So for that, like building recipes case, we create a system prompt template for us to put that information in. So in the case.
Where are you putting in the patient information? That's on a different page.
Yes, so the patient information is last one. All right. So the patient system from uh, give me 1 minute. Still figuring out a different laptop.
Oh.
Okay. No. Email. No, I meant the.
Full screen is chat.
Yeah, that's fine. Okay, that's fine. All right. So okay. So let's take a specific use case of asking an LLM to be a culinary assistant, so that culinary assistant to give me a recipe such that that is in low calorie and it's safe in my allergies, basically. So okay, I'm asking the LLM to be an assistant such that it's a career assistant recommending personal dishes. So, and the use cases, Thank you for your patience. It's getting used to new laptops. So, and I'm asking it to create a locality system. So now I'm also, okay, now the question is, what are the information I have that will be useful for this? So so I would input a sample information. So like, I'll show the data that I'm inputting right after I input it. So I have a CSV saying, okay, whether the,
David, I
yeah.
don't think you're sharing the full screen, so we are seeing like a blank thing.
Yeah.
Oh, okay, here a second.
Yeah.
Give me a second.
No. Share the whole screen.
Okay.
Okay. Is it visible? All right. So I'm inputting a sample data set of information that I have. I'll show the CSV file. Just give it a second. So I input that. So the information I have is system prompt, user prompt, and the sample information that I have for a specific patient. So I'll just generate. Until that, I'll
The data set, right?
yes, I want to. Oh, okay. So, this is a sample data set that I input. So I have the information of whether there is a diagnosis of diabetic, whether what's the person's height, what's the person's weight. So these are the, like what we earlier said, these are the information that are specific user case or pre-trained LLM. Like though that specific information that I'm injecting to the prompt is the information that we have here. So then, okay, we have generated the system prompt. So to generate the system prompt, the system template itself, you can go to view and update. Okay. So here, this is the system prompt that the LLM generated. So it's saying for a specific person, inject their age, gender, and diagnosis into the system prompt in this template format. So one other thing, we can use this view and update function to to give the control back to a specific, like the user. We allow like updates to this. So we can update the system prompt template. So when we're running an experiment, that is replicated among everyone. And then, and the other functionality is basically we can test it on several stuff. So like the earlier use case that we used to generate, if I use the CSV again.
So when it used your sample data to generate the template, it only took a single row,
Yes. So
but you've got like what, 5 rows or something?
yes. So the idea is in the initial data set, we don't even actually what we're checking is what are the information we have. So in other words, column names. So, okay, what are the column names that we have? What is the information that we are given? So we can test generation. So this is generated to 3 people because there's only 3. So age is populated and the diagnosis is populated. So we individually create for a specific scenario a system prompts using the template. So this is used to, so when we go down, we can we can see the whole pipeline picture. So here we are using that user prompt and the sample prompt that was generated. So this is not the template, this is populated with that single specific row. So,
But this is like for the first person.
yes.
Okay.
So
Not really.
for the,
I'm not really seeing that this is person 1 who does have diabetes and is
yes.
severe or something.
So this is for the first row because this is in
Oh,
this specific set.
Did. Okay.
It's the pipeline step. So
Okay.
it's just showing for a person,
It's kind of giving the taste of.
taste of
But you're not running the experiment yet. You're
running an experiment yet, like a whole scale.
Preview of.
Okay.
It's happened in the pipeline.
Okay, sorry, I got confused. Thanks.
So, and we show kind of an LLM answer according to that specific scenario. So it's giving an ingredients, mixture of pudding base, said chili. Okay, now we have the injected information. Now we want to create, the second step of our process would be to extract the information that's necessary for this. So that would be, so we accept the generated system prompt template, and then now, okay, once an LLM produces that answer, what are the things that we need to extract for it to be tested? So that extraction, for that extraction, so if it's a recipe, what are the names of what are the ingredients involved would be the common thing, right? So in our case, would be all right. So that would be so extract all the ingredients without, so the way we have generated it is the way we have written it is we are giving the instruction to the LLM on how to, okay, if what are extract the main ingredients and retain a singular noun of what that is. So bananas would be banana. So we want a singular noun because it is searchable. And so we have also given kind of some examples of what to extract. So we give it the simple natural language extraction rule, and then, okay, so what we generate using the LLM here is basically a rule. So what we're doing in the information extraction step is telling an LLM, okay, these are the specific things you need to extract, and asking it to extract it. So what this rule represents is the rule that is generated from an LLM to tell a LLM what you need to extract. Okay. So it's saying extract all main ingredients with subsidiary. So previous conversation, this is kind of like a structured output concept that we discussed. So, okay, we got the rule. So again, as the previous step, we could update and like test it on several stuff. So this is a generated output of the what we show. We can test it. So the information extracted output would be almond, chia, vanilla, cinnamon, berry, that kind of information. So these are the extracted entities that we're taking out for us to check on this Spark.
So why do I not see that those are ingredients? It seems like the extracted output should say ingredient :
They are in the answer. Chia, almond being the first.
Almond milk.
Oh, there, yeah.
Yes, it's
Why is that a cup, a teaspoon, and are not extracted?
because it didn't ask for it to be extracted.
we are only asked.
As for ingredient.
They didn't ask for it.
For nouns,
No, so extract all the ingredients, represent them as singular nouns.
But a cup is a
Actually,
singular noun.
Not asking for the quantity.
The cinnamon out of the cup of teaspoon cinnamons. Not the amount, basically the underlying ingredient
So it figured out that cup is referring to the amount. Yeah.
and the teaspoon.
All right. Okay, that's information extraction.
I don't know. The ingredients is fresh berries, not berry.
So the reason behind that is in the knowledge graph, the entities are in the singular noun form, like berries, not as fresh berries. So to query to the LLM and get the attributes out of the
That matters for ingredients, right? I mean, it's fresh berry versus frozen berry is a different ingredient.
Yeah,
But
okay.
apparently in the both databases or knowledge graphs, they are in like very rudimentary form.
So they don't distinguish between
Yeah.
fresh and.
Don't blame it on their extraction, blame it on the crappy
I mean,
knowledge graph. It's,
Actually, that's the reason.
no, I'm serious, I'm serious.
That's the reason we are putting the like extract instruction calling extract the main like that extract mean and dairy products in the base form, because like they database do not have like, let's say a pork ribs. It only has the entity as pork.
So it is compared to a knowledge graph? And
Yeah.
that's how it's extracted, so that's how it
No.
knows this ingredient?
No,
It's going to be validated in a later pipeline step against a knowledge graph that has particular structures. Food KG is the knowledge graph that's established. What they're doing is they're purposefully giving it natural language instructions to extract the ingredients in a particular way, okay, that aligns with how these different foods are represented in the knowledge graph so they can do a comparison. So they want the ingredients listed in this way so that they can turn around, do Sparkle queries into a knowledge graph that has it represented the same way and compare it.
So can we maybe stop interrupting and see one end to end run of that? And then we'll better be able to understand this, and then we can come back and
Yep.
micromanage.
Okay.
okay. So, and the next step would be to kind of, so in the previous step, we extracted the ingredients that we need. So next is to get the attributes of those extracted ingredients from a knowledge graph. So this is kind of the base, like what we discussed earlier, it's the base truth that we are validating against. So for this specific thing, we aren't using any LLMs to generate. So what we are doing here is basically giving it a Sparkle endpoint or where the data is, and then we are using like a query template on what are the information that you need to extract. So
The reason behind giving the endpoint URL is to make the application robust, use across different knowledge graphs. And we can set up.
So your default was Food KG hosted by RPI, but you're actually going to hit for this demo DBpedia.
DBpedia, yes. So yes. So we create the Sparkle function. So what you mean by create Sparkle function is using those endpoint to create an internal function for it to, given an ingredient, get me the attributes. So again, so this is so in the previous step, we got almond, shea, vanilla. So this is kind of a run example on the raw output of the DBpedia outputs. So we extracted outputs. So here we give the option to download Sparkle responses as a CSV file because we need that. Like for the next step, what we are doing is basically, so now we got the data, we need to format it to a very specific thing because if we notice this is for a single patient or in the initial data, it's a single row, like a singular person. So now we have several ingredients and several values for that specific person's inquiry. Now we want to process that into a basically process one thing, the null values, the NA values we have here. And second, like get it to a singular row for it to be represented. So for that, we kind of require the raw Sparkle output to generate the function that would do the post-processing. So I download it. Okay, it's already downloaded, but okay, I accept the Sparkle function. Then, okay, the post-processing step. So here, like I said earlier, we have the now like a demo Sparkle output. We want to convert it into a single row, compacting all the information of that single person. Second, we want to remove NA values. So technically, the process is robust for a lot of post-processing stuff. It's just, for example, null value removal and duplicate value removal. So those, you can do post-processing stuff for that. Then formatting would be kind of crunching down those information into a single row so that we can show it with that specific person's. So for Wikipedia, okay. So we get the instructions of one select row with the information on sugar G, which is what sugar G means is sugar in grams, and the intermediate category. We are asking it to fill the missing values with 0 and then with 0 column varieties and the ingredients one with dash, and concat all rows to a single one, and for the multiple values separate them with a line. Okay, generate the post-processing function. Okay, so for example, the answers that we got in the previous step, and then the sample output of the post-processing step here is shown here. So for a person, you got almond, cinnamon, berry, and then the extracted outputs from the Sparkle query is concatenated in this. Then we can, again, for this one, we output the specific function that is generated. And if there is anything that we need to change, you can change it in here, giving the user the option to do so. We can test the generated function. Due to time constraints, I'm not going to do this. So for post-processing, so we accept the post-processing pipeline. So now we have all the functions generated. So we can build the specific pipeline. What we mean by build the specific pipeline is generate a machine readable output such that we can use it in the experimentation steps. So, all right, we build the pipeline. Okay, so it's outputted as a JSON file. Yeah. All right, so that is kind of all the steps that we have to go through to build the pipeline. So I'm going to let Nipun take over for the experimentation part.
Now we have the pipeline, basically the functionalities that need to be happen on our experiment. And I will first set up the experiment and like show you what it's like, what the pipeline looks like, because like the experiment run will take some time. As we said, we will put back the pipeline and we can set the experiment scenario by using the data set that we already created the pipeline on. And we set basically the number of tries mean if you need to check the consistency of answers generated from the LLM, we could test multiple tries for. As for now, I'm gonna only go with the single try and I'm gonna check the answers against 2 LLMs. So I started the experiment and in here, system will validate the pipeline, whether it is in the expected form or not, as well as the data set. So meanwhile, let me show you how output pipeline would look like. The pipeline itself has 6 parts, as for my knowledge. First one, the data structure. It needs to say what are the information that pipeline is feeding in. So one thing to note, this is not the exact pipeline we have built, but the prettified version of a pipeline. So these are the columns that pipeline will get the information from. And this would be the system prompt building pipeline that generated from the builder LLM. As you could see, here it is doing the placeholder filling by using the string formatting. And in the second part, since we have the system prompt, now we need the user prompt. So it is the same as what user put in to the system in the pipeline generation process and the information extraction function. So one thing to note here is, another thing to note here is, as you would see, these functions are pretty intuitive and readable. So therefore, if you need to change any update even after the pipeline has been generated, you can do it in here and upload back into the system. It should work. And so this would be the function to extract the information. Basically, this is a structured output generation from the LLMs. Then the Sparkle query, the endpoint, and the query template. So this is why we are saying query template, because it has a placeholder for %s, and finally the post-processing function. So ultimately, this is the the prettified look of the system. So in the meantime, the system has been working and generating the results. So to explain one result here, as you could see, there are two the main sections in the result section. First one is a table. It gives the summary view for the overall results that's been generated by the experiment setup, and we can select a row from the table and get the detailed information of that specific query. So here the query ran on the Llama 3.5 model. The query ID is representing the row ID of the dataset that we got the information here, like age, weight, height, and so on. And this is the answer generated by the LLM. So from that answer, system had extract these ingredients, and on that ingredients, system extract the ground truth information for these 4 ingredients, because all the other ingredients probably Sparkle knowledge graph haven't had entity in the same name. So as you would see now, based on this setup, we have the sugar grams for the ingredients that the LLM recommended and the ingredient categories. From this point, the unit tester or lay user can determine whether the generated dish or the recommended food is in line with the user case. in our scenario, low calorie, low sugar. So since all the ingredients here we are getting as low sugar level, here we are like referring against like standard sugar level called 12.5 considered as the high sugar ingredients. So here since every ingredient here has like lower sugar levels than that, we can, or user can fact validate the generated answer is factually accurate and it compares to the given instruction on low sugar. Also, they can validate the factual accuracy on the user preferences, because here, funny enough, this user don't have any allergies but have a food preference on fruits. So since we are getting the ingredient categories on berries, medical plants, fruit, tree, and berries, they can validate how much percentage of the ingredients are in fruit. Or specifically, if they have an allergy on meat or like some dairy product, they can check against whether the recommended food have dairy or meat. So that's how ultimately this system would help on LLM answer fact validation.
So the query just said low sugar,
Yeah.
right? This output tells me one of the ingredients has 12.23 or whatever number you just scrolled away from.
Yeah.
How do I know that that's low?
Oh, so it is based on whatever the standard you are referring on. So, for the research, we got the level as 12.5 grams per ingredient as the threshold to determine the high sugar level ingredients and low sugar level ingredients. But it would be pretty intuitive in the setup of the ingredient category, because like it's one-to-one mapping.
Okay.
Enrique.
But this definition of what's high, what's low, is it encoded somewhere? Is it encoded on the Sparkle query or just?
No.
Not encoded.
No.
So the person needs to go there and look at the number
Yeah.
and
Yeah.
actually determine it's high or low.
Yeah, so to be clear, this is not actually doing the validation.
Ultimate
I
decision.
mean, in our next gen paper, when we did this with the diabetes and checking the glycemic index, that was done in the analysis would come after this.
Yeah.
So we would take this data set and as part of our validation criteria in our analysis, we would look at that and we'd choose that threshold 12.5 or whatever you said. And we would do an analysis based on that, but we'd also do it for 100 patients or rather than 5 or whatever you did for this demo.
Yeah.
I don't get it. Those numbers, the sugar, do they adapt from different ingredients? So maybe each of the ingredients is low sugar, but they're all together, maybe not, right? I just don't quite.
So, yeah,
Sorry.
we're not looking at that combined thing, but you could, so again, but that's a similar, no, well, now, wait a minute, okay, that's a similar thing to Jim's question about the 12.5, okay? What is your analysis, given this extraction of the data, what is what's the next analytical step? That is to take those numbers and check them against the graph. So we've extracted the entities from the LLM answer. We've looked up what their, in this case, their sugar levels in our paper, the glycemic indices. And then we're going to analyze that and see that if our criteria is the sum of all of the ingredients, the sugar levels of the sum of all ingredients, then that is our criteria. What we're doing here is the step before that.
Getting that information required to do the criterion.
this is not doing the actual analysis against whatever that criteria is, whether it's checking single ingredients or checking the sum of the ingredients.
But you're not going to check the sum of the ingredients, right?
Well, that's an example you just
You're going to go to the
gave.
recipe and look at whether they're telling you how much,
Because the
sugar
quantity also.
you get for a portion. Because trying to figure out from these ingredients what the sugar level is for one portion is hard.
So, okay, so what that does is that questions the whole premise of the experiment. And it's similar for the diabetes thing, where we're looking for recommendation. Well, I guess in that case, we're just looking for a set of ingredients, not, you guys were actually looking for recipes.
So the previous example, I think the food KJ one would have been easier because it's just it's a quantity less value, whereas technically it's glycemic index.
Like, you were looking at the GIs.
Yeah,
For ingredients?
Each ingredient.
In the rest?
No, just the ingredients.
just the ingredients, because for that, I think it is kind of, I wouldn't say quantity independent, but it's somewhat quantity independent because it's a measure of how fast it converts to sugar. So from what I saw, it's even for that, it's the recommended level is not just the quantity, it's anything about this, it's not that good for a diabetic person. So that would be somewhat independent of the quantity, but for sugar, that part also does have an effect.
So it does pose that, from an experimental standpoint, when you're extracting these values from DBpedia, what are the units?
So these are in grams. That's why it says sugar G. It has grams. So basically,
Per some standard amount of.
1.2
Grams of money.
grams per what?
They're asking is.
oh,
So for how
Hey, per ton.
nice how
So that's a legitimate
Yeah.
unit. It's 3 points off.
I'm not sure about that.
but I'm pretty sure it's under the definition of how DBpedia handles it, right?
Yeah.
There's like can just check.
Per 100 grams or something like that.
Well,
There must be some standard.
Of chopped almond, I mean, you could probably get a glycemic index of some quantity of almonds and then calculate it.
Yeah.
Thanks, Jim.
Exact reason to
So the,
Yeah, another question that
go ahead.
so I'm assuming currently there is no way to encode any metric of what it means to be like a good
Yeah.
answer or not, right?
it is outside of the system.
Right now it's also,
Yeah.
but if that could be incorporated at some point, that would probably allow us to benchmark models, right? As well. So which
Yeah.
Yes.
Yeah.
have that metric encoded, be able to be calculated.
The reason to skip that is it would be a huge process as same as this whole thing, because defining the such a validation could either be independent for each ingredient, or it could compose every knowledge for the
You have that here.
answer.
You did 2 different models for each of the pages, right?
Yeah, it's
So can you just toggle between?
For the exact user, let me go for this is the same user. I guess. No, this is not for the same user.
yes.
When it's
Sorry, I did.
zero as the sugar, it's because it's not found in the
One.
kg. Is that,
Sorry?
so when you have like this sugar level as 0, it's because it was not found in the kg?
Yeah, and we set the post processing to make it filled up with 0.
Okay.
So this is one user. Information.
So with the diabetes experiment, there was a lot of uniformity in what's coming back. But are we actually looking at inpatient different answers?
Yeah, same patient, different answers.
So,
It has some level of uniformity because like both LLMs had recommended chai, almond milk, and berries and bananas.
The other one.
One of them was a fruit salad, a berry banana salad.
Yeah. Oh, it's
He wasn't trying to put this
fine.
one.
didn't you have like the patient, some kind of patient index in your?
Yeah, it's for it.
Patient information.
That's not query ID.
Also, like patient information would ideally could see in here.
Oh, but you're not, I see what see, when we did this for the NextGen paper, we actually included a patient identifier
I mean, query ID is sufficient.
prompt. So we could track,
No, at this pipeline, we skip it.
yeah, it's for precisely this reason, it's kind of useful to have that.
Actually, the patient identifier would be this query ID. Because like each patient has individual row. Query ID shows which rows information.
Right, but when you do the test with one model and then do the test with next model.
Yeah.
It should be,
Same.
It's, the query ID is basically the dataset ID.
I got it, okay.
This one actually has the number of grams of sugar per portion, approximately. So for the recipe, oh wait, did you switch? Not the parfait. The salad had a breakdown, a nutritional breakdown, that actually said it was 15 grams of sugar for, the portion. Yeah, so you get down to 15 grams for.
Right, I see it there, 5 or 4 grams sugar. 50.
Yeah, so, I mean, that's more, I think, what you're really looking for, like how good is this overall recommendation?
So how is this information about patient being utilized yet? I don't see that this has anything to do with.
Oh, so one example would be, as you would see, like here, the patient's preference is like fruit. So that could be the reason to give fruit in here rather than having
What about the fact that she's?
the carnivore.
No, that's this right there in the system prompt.
Right, I see that, but how that is affect the recipe?
That's what we are trying to analyze. What information would
So if you change it to male.
Go choose a different
The males will get different.
yeah, this is a main page.
It's egg spinach. Okay.
Female and male might make a difference for height and weight for your BMI, which might weigh in here, I don't know. Because there's different charts for male and female. Yeah.
So whether there is a difference can be identified from the
Generated answer.
generated answers, right? So
That's a
that-
processing.
my point is like to find that there is a change, what we're doing is basically getting the information to check whether there is a specific bias or anything.
Okay, I understand it reacts to what kind of food this person prefers.
Yeah.
Whether it's male or female or whatever, or how high it is or tall, I mean, how much weight, that doesn't seem to have anything to do with the recipe. Just the fact that this person prefers meat.
Yeah.
So,
The other person prefers fruit. That's the only thing that matters.
so, well, let me say this, that's a hypothesis. Okay?
Well,
No, let me finish my sentence. That's a hypothesis. The way you test that is you use this pipeline, you synthesize 100 patients and you fix some of the variables and you change some of the variables and you actually see, in fact, does height make any difference or not? And how do you differentiate that between just the the sheer differentiation is going to happen because it's a new submission to the LLM. You know, like you've got identical patients with identical criteria submitted
3 or 4 times.
3 or 4 times, which is in our paper, that's exactly what we did is we went both vertically, you know,
Yeah.
100 patients, but for those patients, we'd submit it like each one 10 times.
Yeah, same LL.
The variation. So I have exactly the same conditions and I submit them 10 times. What's the variation within the same model? And to look at that. And then you can actually say, now actually it doesn't care about the height or it's within a randomness.
Yeah, and I was wondering about the diabetes. You would think that that matters, but if you're asking for low calorie, low sugar, the diagnosis of diabetes might not matter.
But actually, there are
So,
some
but so on that point, that's if what you're looking for is those cases where you specify diabetes, it should matter. And so it should not recommend ingredients with high glycemic index, and it does. Okay, and you want to see, so the actual context of the experiment is it bad at doing these recommendations or not?
Right, but the user prompt is low sugar, low calorie, so it's already low sugar in there. So you should presumably have a low glycemic index.
yeah.
You should.
Just from the user prompt.
That's also like a fact to check against.
Mhm. Okay, I know you have to run.
It's fine.
So, yeah, so what, yet again, you know, these guys have cooked up a demo that's based on a different use case than what our NextGen, you know, what the actual paper was based on. If you recall, we did that in our 2:00 meeting a few weeks ago, last month, I think it was. They cooked up a demo that was based on
School recommendation.
in fact, they did it kind of on the fly. So, which is kind of demonstrating this flexibility. One piece of feedback that you should get from this is you gotta be very careful. You know, so Vladia, when she designed that experiment in the, for the NextGen paper, she was very careful about utilizing glycemic index. So her criteria, her thresholding had some basis. What you guys did here, as you can see from the reaction, is a little bit loose, okay? Because you were just kind of pulling that value. So it's very impressive. They pulled it out of DBpedia rather than the food KG. So the goal of using a different knowledge graph with a different, that's based on a different ontology for extracting information with a different structure. But you got to be very careful about what you're doing as an experiment. With the paper that we wrote late last year, we had 100 different patients, and we actually did it against 2 different models, and it was all about whether, you know, the question's very similar to this question, but did the recommendations run up for I think it was healthy snack, right? Recommend healthy snack for a high energy healthy snack
Before the gym
workout.
With your gym workout.
And that was the question. And the patient information included their condition, and what their preferences were. And then the lookup validation was against food KG, which included the glycemic indices for the contents. And so and then the analysis that we did in the paper was, should it have recommended this or not? And how often did it fail?
And what was the ground truth for should it have recommended it?
Sorry?
What was the ground truth for should it have recommended? You know,
I think it's 50. I think it's 50.
55 glycemic index
65.
considered as a threshold for high glycemic index. Low.
Yeah. And yeah. And what that paper was done based on this, like manually doing this experimental workflow with using ChatBS manually. And so lots of manual submissions over long weekends. And the mission that these guys had was to automate that and to automate a lot of the, like, describing what needs to be extracted rather than like manually extracting that sort of thing. So, all right, guys.
Thank you, John.
Thank you.
Thanks for coming.
Thank you, Tomek, for asking tough questions.